Hello, Calc BC. I accidentally did not save or I didn't record it. I thought I was recording it, but it wasn't recording. So I have to do this over again. So example number 2, the table below gives the velocity in feet per second of a particle moving along a horizontal axis. The velocity v is a twice differentiable function of time. At t equals 0, determine whether the particle is moving to the right or to the left and explain how you know. So I would say that since, my v of 0 equals -4, and -4 is less than 0, the particle is moving to the left at a rate of 4 feet per second. And then, is there any time during the interval from 0 to 15 seconds when the particle is at rest? Explain your answer. I do notice that between here and here, it has to go through 0. So I can use the intermediate value theorem, but I have to state that it's continuous. So I have to say that v of t is differentiable, so it is continuous. And that's what they stated up here, so I was able to say that. Remember, if it's differentiable, then you can automatically assume it's continuous. And that is one of the things that you need for the intermediate value theorem. Since v of 2 equals -1, which is less than 0, and v of 3 equals +1, which is greater than 0, then by the intermediate value theorem, there exists a time in that interval from 2 to 3 such that v of t equals 0 and the particle is at rest. Remember, intermediate value theorem says that it takes on every value. The continuous function takes on every value in between there. So that's why we can use that. All right, part C, use the data from the table to find an approximation for v prime of 8. Explain the meaning of v prime of 8 in terms of the particle motion. Show the computations that lead to your answer and indicate the units of measure. So since we don't have a value at 8, we have 7 and we have 10. So 8 lies right between there. So we're going to be using these two to do an approximation. So we say that v prime of 8 is approximately equal to 5 minus 3 over 10 minus 7. So 2/3, and that would be feet per second, and then per second. Remember that when you take that velocity, it's going to be the y value, feet per second, right here, over the x value. And you could write it as feet per second, or you could write it as feet per second squared. They do not cancel, okay? And we're going to say, so at t equals 8, the particle's velocity is increasing about 2 feet per 3 seconds squared. What I did want to stress is that I should have added right here, and I did this when I was with the kids earlier today, but I didn't just do it right now. We should have written this to be approximately equal to v of 10 minus v of 7 divided by 10 minus 7 is equal to, I should have written this in there because that is basically you using the math to explain the computation, okay? If I hadn't put that in, I would have had to explain why I used 5 minus 3 over 10 minus 7. Okay, so find the average acceleration of the particle between 10 and 12 seconds. Explain what this number means in terms of the particle's velocity on the interval. So our average acceleration, we're going to be using velocity. Just like on average velocity, we would use position. So this is going to be our v of 12 minus v of 10 divided by 12 minus 10 to get our average acceleration. And so this is going to be 3 minus 5 over 2, which is a negative 2 over 2, which is a negative 1. And since this is average acceleration, this up here is our feet per second, and then this is our per second, our second per second. So this is going to be negative 1 feet per second squared. And average acceleration means velocity was decreasing on average at a rate of 1 foot per second per second. And I didn't mean to put a little dot there, but somehow I did. So notice that I said decreasing, but I didn't put negative because this negative told me decreasing. All right, the next one is let A of t equal V prime of t. Is there a time equal t equals c guaranteed such that A of c is 0 in the interval from 0 to 15? Justify your answer. All right, so now, because V of t is differentiable, on that 0 to 15 interval, A of t is continuous. And so our V of 12 minus V of 10 over 12 minus 10, that negative 1 is less than 0, and our V of 10 minus V of 7 divided by 10 minus 7 was our 2/3, which was greater than 0. Oops. Thus, by the intermediate value theorem, there exists a t in between 7 and 12 such that a of t is 0. Okay. So that is example 2. Oh my gosh. So example number 3, the graph at the right is y equals v of t. And the velocity of an object is moving on a line over the time interval from 0 to 10. Assume that the positive direction is to the right. On what interval of time is the object moving to the right? Since this is velocity, it will be moving to the right when it is above the x-axis, and it is above the x-axis from 4 to 10. So where the velocity is greater than 0, the object is moving to the right. So on the interval from 4 to 10, the object is moving to the right. Now, before we do any of these other ones, I do want to stop and I want to look at the area between the curve and the x-axis for each of these intervals. So I'm going to do from 0 to 2, and the area between the curve and the x-axis, I would take negative 10 times positive 2. So that's negative 20, which basically means left 20 units. And then from 2 to 4, we have a, I'll do a different color, maybe orange. We have a triangle. And so for that one, it's 1/2 base times height. So my base is 2. My height is, I'm going to say negative 10. Because it's below the x-axis, somehow you have to do negative. You could just say positive 10 and then just put a negative on it because it's below the x-axis. But this is going to be negative 10. So another 10 units left. Kind of made everything look weird by changing colors. Sorry about that. But the next one that I want to do is this one from 4 to 6. And that is area of a triangle. So this one is 1/2. Our base is 2. Our height is 15. So that's 15. So this is right 15 units. And then our next one is from 6 to 8. And that is a rectangle. It is 2 by 15. So that's 30, which is right 30 units because it's positive. And then I'm going to put the last one up here, 8 to 10. Is a triangle, base of 2. So 1/2 times 2 times 15. So that's a positive 15. and again, write 15 units. The reason I wanted to do that is I know that we're going to need that on this problem, and it also gives you a chance to think about if you have a velocity function. If you wanted to find the distance traveled, you're going to have to take the area between the curve and the x-axis. If that area is below the x-axis, that is left-hand movement or downward movement, depending on how they've defined it. So when is the object speeding up? Okay, so let's think about what that means. Speeding up is when you've got the same sign for velocity and acceleration. So when v of t and a of t have the same sign, the object is speeding up. This happens on the t interval from, now let's think about it. So your velocity is negative, your acceleration is 0, from 0 to 2. Your velocity is negative, your acceleration is positive because the slope is positive from 2 to 4. So those are, different signs. Here, your acceleration is positive and your velocity is positive because it's above the x-axis. So this from 4 to 6, that would definitely be where they are the same because the slope of the tangent is positive and it's above the x-axis for velocity is positive. Here, your acceleration is 0, so no. And here, they're opposite signs, so no. So this happens on the interval from 4 to 6. And then I put on this interval from 4 to 6, v of t is greater than 0 and increasing. And the reason why we know it's increasing because our a of t is greater than 0 also. Okay, they have the same sign. And when that a of t is greater than 0, the velocity is increasing. How fast is the object moving at time t equals 3 and in what direction? So how fast means what is the speed, and that is the absolute value of velocity at 3. So this is the absolute value of -5, +5. That is our speed. So the object is moving left, so in a negative direction, and the speed is 5. They didn't really give us units, did they? So what is the average velocity over the time interval from 0 to 4 and from 4 to 10? Show the computations that lead to it. So we're going to do the interval from 0 to 4 first. And this is our average velocity. So we would be using our s of 4 minus s of 0 divided by 4 minus 0 to find our average velocity, okay? And our s of 4 is basically from 0 to 4, you've gone a total of negative 30. So this is a total of negative 30. I don't know why I put, anyway, negative 30. And so that is your, from 4 to 0. That is your displacement. So negative 30 divided by 4 is negative 7.5. So that's your average velocity on that interval, distance over time. And then for your t values from 4 to 10, your average velocity is going to be your s of 10 minus s of 4 divided by 10 minus 4. And for that one, your s of 10 at 10, well, the distance between 4 and 10 is going to be 15 plus 30 plus 15, right? So this one's going to be basically your distance traveled there, 15 plus 30 plus 15 divided by 6. And so that's going to be 60 divided by 6, which is 10. So that is your average velocity for that interval, and this is your average velocity for that interval. They didn't give us units, so we don't have to put them on there. But remember, this is basically your distance divided by your time. So what is the total distance traveled by the object? Show the computations that lead to your answer. So for that one, you know that it's in a negative direction, but it's actually, like this would be the absolute value of negative 30, because they're actually moving 30 units. And then you would add up your other 15 plus 30 plus 15 to get your total distance. Even though it was in a left-hand direction, the displacement you would subtract, but on total distance traveled, you're going to take the negative and make it positive. So that's going to be 30 plus 60. So it's going to be 90. Total distance traveled, 90 units. When is the object slowing down? Justify. So when v of t and a of t have opposite signs, the object is slowing down. And this happens on the interval from 2 to 4, because look, from 2 to 4, your velocity is under the x-axis, so it's negative, but your slope here is positive. So you have positive acceleration and negative velocity. And so I said this is where v of t is less than 0 and a of t is greater than 0. And then it also happens on the interval from 8 to 10. This is where your v of t is greater than 0 and your a of t is less than 0. And here I could have said, and v of t is less than 0 and increasing. I could have said, instead of this, I could have said increasing. I could have said, instead of this, v of t is greater than 0 and decreasing. Remember that that the derivative here is going to give, if it's positive, it's going to give where that original function, which would be v of t here, is going to be increasing or decreasing based on the sign of it. When is the velocity increasing? So the velocity is increasing when a of t is greater than 0. When a of t is greater than 0. And this happens on that 2 to 4 and 4 to 6. Okay, so you've got a positive slope here and you've got a positive slope here. So that's when velocity is increasing. On what interval does the object move at a constant speed? And so the object moves at a constant speed on 0, 2, and 6, 8. That means there is no acceleration there. That's where your acceleration is 0. Okay. And then the last few are calculator questions. So example number 4, an object moves along the x-axis for time t between 0 and 6. The velocity of the object at time t is given by v of t equals ln t, blah, 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 blah. For t equals 4, is the object speeding up or slowing down? So we would have to calculate our v of 4 and our a of 4 to see what signs they are, to see. And I would go to my Desmos calculator for this. I saved it. I've got 4.2, example number 4. I put in the red, that is your original function for velocity, and in the green, that is your acceleration for this example number 4. And so I did find the acceleration function, so you guys might want to try that. And it is in here. You can't really see the whole thing the way I've got it because I'm showing you. I wanted you to see what... oh my gosh, how's that move over? There we go. I wanted you to see what V of 4 is, 4.9 or 4.497, and A of 4 is negative 2.713. Okay, and these are your two functions. You can see the points right here and here. So 4 comma 4.97 and 4 comma negative 2.713 for this function. And so we'll go back here and we'll say that this one was 4.497 and this one was negative 2.713. And I said, and these are squiggly because they're not exact, but since V of 4 is greater than 0 and A of 4 is less than 0, comma, I put opposite signs mean the object is slowing down. And if you watch the My AP video, he does a good job of explaining what that is. So please make sure you watch that because he does a good job at t equals 4 seconds. At what time between 0 and 6 does the particle change directions and justify? So if we go back to our Desmos, there it was. And we're looking at the red one is our velocity function. And I wanted to know what that, where that 0 was. It's at 0.391. And it also changes at 5.008. So on Desmos, you can just put your finger there I think. I mean, I'm using my pointer, but you can just put that there and you've got your values. Okay, so I'm going to go and we're going to say that that's where that velocity is 0. So we're going to say v of t equals 0 at t equals approximately 0.391 and t is and v of t changes, oops, sorry. I forgot I went into a different explanation. And v of t changes from negative to positive. So the object changes from left to right, from moving left to moving right, because it goes from negative velocity to positive velocity. And then I said, then at t equals approximately 5.008, v of t equals 0. So the object changes direction again changes from right to left, because it's changing back from positive to negative. So that means that the object's direction is changing from right to left. Okay, example number 5. A particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given in meters per second by the function. What is the acceleration of the particle at t equals 4, and what does this tell you about the direction of the particle? So again, I put that in my calculator, in the Desmos calculator, and so I'm going to save. And this one is example number 5. And here is my original function. I know you can't really see the whole thing, but and here's my derivative. I did calculate my derivative. Oops. And so it was asking what is the acceleration at t equals 4? So I put 4 in to acceleration here, and I got that negative 1.890. And so they said, what does this tell you about the direction of the particle? Well, since that acceleration is negative, that tells me that my my velocity is decreasing, and it tells me because my v of 4 is positive and my a of 4, you can see it right here, and my a of 4 is negative, then I know that the particle is slowing down. Okay, and I did not put that. I put the particle as being pushed to the left at a rate of 1.890 meters per second squared. So I put that v of 4 is greater than 0, a of 4 is approximately negative 1.890, and I said the particle is being pushed to the left because of that negative. I knew it was being pushed to the left because acceleration is like a push at a rate of 1.89 meters per second squared. And so the direction of the particle, the velocity is positive, so it's moving to the right, but it's being pushed to the left, so it's slowing down. An object moves along a line between 0 and pi. Its position is given by this. What is the velocity when the acceleration is 0? And so I need to know when for. And so if I look at my graph, and I can go back to Desmos and show you what I'm talking about, but it's going to be at about t equals 1.617. And so if I take the velocity now, I probably would put this value in x. I would probably store it in x and then find my v prime of x, right? I'm going to say my v prime, not my v prime, sorry, my v of x, but my v of 1.617, but I would be putting in, that x so I can make it more exact, is approximately negative 1.925498. I went ahead and took it out several places just so you could, see what was happening. But the object is moving to the left at t equals 1.67 when the acceleration is 0 because of that negative. So the particle, or the object, I should say, the object is moving to the left. Oh my gosh. Sorry about that, guys. To the left at t equals approximately 1.617 when the acceleration is 0. Because that is what we found. That's how we found that t value. We knew we were looking for when our acceleration was 0. Okay? And then a particle moves along the x-axis, and the velocity of the particle is given by that. Find the time t when the acceleration is 0. So again, we're looking for a t when our acceleration is 0. And I'm going to go back to my Desmos. And example 6 was the one that I just did with the 1.67 for the t value when the acceleration was 0. Because I look here and my acceleration is my green function, and it's 0 here at 1.617. So then I put 1.617 into my velocity function, and I got that negative 1.925. So that's how I got, these values on that graph. And then the one we just talked about, here's the one we just talked about, example number 7, find the time when the acceleration is 0. So I saw that the acceleration function is in blue, and there's my 0, 2.152. And so it says, what does this mean about the velocity at that instant? You can see that the velocity is positive at that instant. Okay, it's a positive 1.163. So let's go back, and we said that the acceleration is 0 at t equals approximately 2.152. And so I said when a of 2.152 equals 0, this means velocity does not change, right? Because the acceleration is 0, so it is not being pushed either way. It's just velocity is not changing at all when acceleration is 0. At time t equals 6, what is the velocity and acceleration of the particle? Is the particle speeding up or slowing down? So we're going to be looking at our v of 6 and our a of 6 to see what's happening. And if you do look at that, it's our v of 6 is at 0.709, and our a of 6, and these are approximates, sorry, those are squiggly, negative 0.148919. And I said, since the signs are opposite, at t equals 6 seconds. Actually, it doesn't say seconds, but at t equals 6. So I guess we don't have to write seconds. But they will tell you on the AP thing that you really need to write the units. So I guess they're not going to give you problems without units. Oops. Oh my goodness, sorry. So, oops, I'm still on. There we go. The particle is slowing down. Okay. And I think that's it. Yep, that's it for our lesson. All right, good luck with homework, guys. Thank you.